Today we are going to talk about divisibility rules and ways to tell without actually doing the division if a number is divisible by certain other numbers. And it's not going to be for every value, but it's a good way, at least to get a beginning understanding of if two numbers are evenly divisible. Um, so just a reminder, if you have any chapter 4, lesson 5, or lesson 6 material to turn in, that um, that can be done. It's in the chapter 4 folder, which is now been grayed out, but that's okay. You can still turn in, you can still access that folder, and you can still turn in material in that folder. And then also, if you have anything from 7.1 or 7.2 to turn in, make sure you get that done. There was a quiz assigned on Tuesday. So again, make sure that gets done, the review and the quiz. Um, should be done by end of the day today to stay kind of on schedule. And then today's note check and homework should be done no later than Sunday evening, again, to stay on schedule. Also, a reminder for registration. I believe, and I've been told, that your registration, when you um, take a screenshot of your Infinite Campus page, um, that would be submitted to your civics class or your social studies class. Um, if you have questions about that, ask your social studies teacher. They are the ones kind of taking care of this. Um, um, and if you're having issues, it would be good to talk to them or your counselor would be another good resource there. All right. So let's move into divisibility. So, just again, this is, I should, page 11 in your packet if you have it. There are some quick tests you can use to see if a number is divisible by another number. Divisibility rules can help you find if a number is divisible, and the easy ones are 2 and 3. 5 is pretty easy, 10 is pretty easy. 4 has a rule that you can use, and we're just going to talk about those. Um, all right. So, um, for 2, all you have to do is look at the last digit of a number. If it's even, the, the number is evenly divisible by 2. If it's not even, then it isn't evenly divisible by 2. So for instance, 14 would be evenly divisible by 2. 20 would be evenly divisible by 2. 192 would be evenly divisible by 2. So the last digit has to be either a 0, 2, 4, 6, or 8. If that's true, then you're evenly divisible by 2. The rule for 3 is a little more interesting. What you do is you add up all the digits, and if all the digits add up to a number that's evenly divisible by 3, then the number is evenly divisible by 3. So for instance, we could have 18. When you add up the 1 and the 8, that's 9. 9 is evenly divisible by 3. 456. If you add 4 plus 5 plus 6, that's 15. Now, you get a 2-digit number, so there's a choice. You could say, well, yep, 15 is evenly divisible by 3. Or you could say, well, 15, 1 plus 5, 6. 6 is evenly divisible by 3. Either way would work there. One more, let's go with something easy, maybe 303 as an example. With 4, you look at the last 2 digits. If the last 2 digits are divisible by 4, then the whole number is divisible by 4. So 524. Well, you look at the last 2 digits. 24 is evenly divisible by 4, so the whole number is divisible by 4. 9,340. Again, just look at the last 2 digits. 40 is evenly divisible by 4, so the whole number is evenly divisible by 4. One more. 7,296. So you look at the 96, and if you're not sure, you could certainly divide it out. But 96 is evenly divisible by 4, so that whole number is divisible by 4. Divisibility by 5 is, I think, even easier. A number is divisible by 5 if it ends in a 0 or a 5. So 40 is evenly divisible by 5. 95 is evenly divisible by 5. 1,015 is evenly divisible by 5. 2,000 is evenly divisible by 5. All right, so there are the first couple of rules. Other rules are going to depend on these rules. So the rule for 6, the number has to be divisible by 2 and divisible by 3. So in other words, the number has to be even and the digits add to a number divisible by 3. So 996. It's even. And if I add the digits, 9 plus 9 is 18, plus 6 is 24. 24 is evenly divisible by 3, so 996 would be divisible by 6. 100. I'm going to get in trouble there. $138. Again, if you, it's even, so it's divisible by 2. If you add the digits together, 1 plus 3 plus 8 is 12. 12 is evenly divisible by 3. So good to go with that one. For 9, again, you're going to add up all the digits. If they add up to a number divisible by 9, the whole number is divisible by 9. So 207. 2 plus 0 plus 7 is 9. 9 is evenly divisible by 9. That works. 819. 8 plus 1 plus 9 is 18. 18 is divisible by 9. That works. Divisible by 10 if the number ends in 0. Again, I think this is one of the, I think this is an easier one, especially to come up with examples. 20 is evenly divisible by 10. 1,950 evenly divisible by 10. 490 evenly divisible by 10. They all end in a 0. A number is divisible by 12 if it's divisible by both 3 and 4. So the digits have to add up to a number divisible by 3, and the last two digits have to be divisible by 4. So maybe 324. The last two digits, 24, are divisible by 4. And if I take 3 plus 2 plus 4, that's 9. And 9 is evenly divisible by 3. 72. 7 plus 2 is 9. That's divisible by 3. And 4 divides evenly into 72. That one works. All right. So let's move on. So here, just a couple of examples. Is 107 divisible by 3? Now let's see, divisible by 3. If I add the digits together, 1 plus 0 plus 7, that's 8. Is 8 divisible by 3? I can't remember, so you'll have to let me know. Does anyone know, is 8 divisible by 3?
No.
No, it's not. Okay, so the answer here is going to be no. Because the sum of the digits is not divisible by 3. What about 240? Is that divisible by 5? The rule for divisibility by 5 is the number ends in 5 or 0. So, well, this one ends in a 0, so this one is divisible by 5. 96. Is 96 evenly divisible by 6? In order to be evenly divisible by 6, it has to be even, which it is, and it has to be divisible by 3. So if I add the digits together, 9 plus 6 is 15. 15 is divisible by 3, so this is a yes. All right. Is 738 evenly divisible by 4? So we look at the last two digits. 38. Is 38 evenly divisible by 4? No, 38 is not evenly divisible by 4. And then for 156, to be divisible by 12 means it has to be divisible by 3. So if I add the digits together, 1 plus 5 is 6, plus 6 is 12. That's evenly divisible by 3. Then I look at the last two digits. Are the last two digits evenly divisible by 4? And the answer is yes. So that one is evenly divisible by 12. All right. Factor pairs. All factors come in pairs. If you want to find all the factors of a number, it helps to list the factors in pairs. You can use divisibility rules and a calculator to find all possible factors of a number. For instance, all the numbers that divide evenly into 24. Well, 1 and 24 work. And that's where I always start. I always start with 1 in the number. And then I try 2. Well, it's even, so 2 is going to work, and 24 divided by 2 is 12. 3 works, 3 and 8. 4 works, 4 and 6. Then I try 5. 5 doesn't work. And the next number I would try is 6, but I already have it. So I don't need to, I can stop. I know I've got all of the factors of 24. So finding all of the factors. And I would write it, I would do it very similar to that example. I always write it separated by a comma. So 1 and 64. 2 is going to work because it's even. 2 and 32. So I check 3. If I add 6 plus 4, that's 10. 3 is not evenly, 10 is not evenly divisible by 3, so 3 is not going to be a factor. 4 is a factor. 4 and 16. 5 is not a factor because it does not end in 5 or 0. 6 is not a factor because in order for 6 to be a factor, it has to be evenly divisible by 2 and by 3. And it's not evenly divisible by 3, so 6 can't be a factor. 7, there is no rule for 7. That one you would just have to try dividing and see if it works. In this case, 7 doesn't work. 8, again, no real rule for 8. You just have to try and see what happens. And when you divide by 8, you get 8 and 8. Now, with factor pairs, if you get a double pair like this, you only have to write one of them. But the nice thing about that double pair, it tells me I can stop. These are all of my factors for 64. And again, always start with 1 and the number, and then go to 2 and 3 and 4 and check. And you can stop checking once you get to a repeated factor. Like if the 8, we repeated the 8. With the example on 24, we got to 6, and that was already given as a factor. All right, so it's even, so 2 is going to work. 80 divided by 2 is 40. The digits do not add to something divisible by 3, so 3 won't work. The last 2 digits are divisible by 4, so the whole thing is divisible by 4. Another way that you could check with 4, look at the factor for 2 or with 2. If that number is even, then 4 will divide it as well. 5, it ends in 0, so 5 is going to work. 5 and 16. 6 is not a factor because 3 is not a factor. 7 is not a factor. 8 is a factor. 9, if I add the digits, I get 8. 8 is not evenly divisible by 9, so 9 is not a factor. And then I come to 10, which I already have as a factor. So those are my factor pairs for 80. Okay, so it's factor pairs, not prime factors. Sometimes we talk about prime factoring. That's not what we're doing here. One and 72. 72 is even, so 2 is a factor. 7 plus 2 is 9. 9 is evenly divisible by 3, so 3 is a factor. And 72 divided by 3 is 24. 72, 4 divides evenly into 72, so 4 is a factor. 18, 72 divided by 4 is 18. Our number does not end in a 0 or a 5, so 5 is not a factor. 2 and 3 are both factors, so 6 would be a factor. 72 divided by 6 is 12. 7 does not, and again, that's just something you would have to try. You get 7 with a remainder of 2. I'm sorry, you get 10 with a remainder of 2. 8 is a factor, and 8 72 divided by 8 is 9. And then my next value I check is 9, which I already have on my list. So there's my list of factor pairs for 72. All right. Factor pairs using negative numbers. So I know um, if I have a negative value, one of my two numbers that I multiply has to be negative. So I could have 1 and negative 32, or negative 1 and positive 32. So this is the way I'm going to deal with that. I'm just going to write it down. 2 is a factor because 32 is even. Negative 32 divided by 2 is negative 16. So I could have negative 2 and positive 16. 3, if I add 3 and 2, I get 5. That is not evenly divisible by 3, so 3 doesn't work. 4 does work. Negative 32 divided by 4 is negative 8. And then if 4 and negative 8 are factors, then negative 4 and positive 8 are factors. The number does not end in a 0 or a 5, so 5 is not a factor. It's not divisible by 3, so 6 is not a factor. If I try dividing by 7, I get negative 4 point something. So 7 is not a factor. And then I'm at 8. So here are my factor pairs. Now, one thing you'll notice on the first set, when we had just positive values, that's all we looked at were positive values. There are some times when you want to look at both positive and negative values. If we go to negative 21, again, 1 and negative 21, negative 1 and positive 21. 1 at the end there is not even, so 2 is not going to be a factor. If I add 2 and 1, I get 3. That is divisible by 3, so 3 and negative 7, or negative 3 and positive 7. 4 isn't going to work because 21 isn't divisible by 4. 5 isn't going to work because it does not end in a 0 or a 5. 6 isn't going to work because 2 is not a factor, and we already have 7, so we can stop. So if we have a positive number, we could, again, start with both values being positive. 100 is even, so 2 is going to work. If I add my digits, 1 plus 0 is 1. 1 is not evenly divisible by 3, so 3 won't work. 4 will work. The double zeros at the end are divisible by 4. It ends in a 0, so 5 is going to work. It's not divisible by 3, so it's not going to be divisible by 6. If I try dividing by 7, I get 14 point something. So 7 isn't a factor. 8, I could try, but 8 is not going to work. It gives me 12 and a half. So we need it to be an integer. 9, if I add the digits together, 1 plus 0 is 1. 1 is not evenly divisible by 9. 10, it ends in 0, so 10 is going to be a factor, and it goes in 10 times. So again, it's a repeated factor. I only have to write it once. So those are my factors. But then I could also have all of those being negative. So -1 and -100, -2 and -50, -4 and -25. Whoops. -5 and -20 and -10. And there's a reason that we want to include both positive and negative, and we'll take a look at that here in the next couple slides. So on page 13, you have this table, and we're going to do just a couple of examples. I think it's actually on page 13 and 14. We're going to do a couple of examples, and then if you would like, you can complete that table for extra credit. That will be an assignment I will have to add to the folder for this assignment. Again, in order to do the extra credit, you're going to have to do the note check and the assignment first, and then the extra credit will be available. So what we're looking at are numbers, or we're given numbers. We want to find their sum. So -6 plus 3 is -3. And we want to find their product. -6 times 3 is -18. So pretty easy if we're given the two numbers. -3 and -8 add to -11. -3 times -8 is +24. So there's an example where the product is positive. The factors we're given are both negative. Now, if you're given one of the numbers and either the sum or the product, you kind of have to work backward. So if you're given the sum, what number do I add to 6 to get +4? It has to be negative because I'm getting a smaller value. So -2. Now, once I have the number, I can say 6 times -2, that's -12. What do I add to -4 to get -12? -8. And if I multiply those two, I get +32. All right. So in the chat, let me know, what number do I multiply by 8 to get an answer of 40? What number times 8 gives me 40? Or maybe an easier way to think about it, what is 40 divided by 8? All right, excellent. 5, good. And then 8 plus 5, that gives me 13. All right, maybe the most difficult question here. What number do I multiply by -9 to get -9? Or what is -9 divided by -9? Go ahead and shoot me an answer through the chat. One is exactly right. Yeah, good. So 1. And again, remember this third column is the sum. So take -9 plus 1. I think that's -8. The end, I think, is more difficult. Now I need to find two numbers that, and I always go multiply first and then add. They multiply to -12 and add to +4. So I know to multiply to a -12, I'm going to have one number that's negative and one number that's positive. So I would look at the factors of 12. Uh, -1 and 12. 1 and -12. Whoops. And if I add those together, I don't get -4. -2 and 6. 6 and -2. Oops, that's not right. Try it again, Mr. Gingrich. 2 and -6. Now, if I add -2 and 6, I get +4, but I want -4. So if I take 2 plus -6, I do get -4. So writing out factor pairs can sometimes help with these types of problems. I need two numbers that add to a negative and multiply to a positive. So now I know both of my numbers have to be negative. And they have to multiply to 3. Well, if they both have to be negative, start with -1 and -3. And if I add -1 and -3, I do get -4. So that has to be my pair. Sometimes those are the most difficult when they have to multiply to a positive and add to a negative. They're also difficult if one of the factors is either 1 or -1. For some reason, students don't like that too much. The 25th example, -1, they multiply to -100 and add to 0. So the only way two numbers can add to 0 is if they are exactly the opposite. So I am going to have a negative and a positive. And again, if you're not sure, start with 1 and -100. Or we did 100 back here. So I'm just going to scoot back 1. Actually, we did +100. But 10 was a repeated factor. So if I have +10 and -10, that adds to 0 and multiplies to -100. Two numbers that multiply to -9 and add to +8. So again, one positive, one negative. So start with -1 and 9. If I add -1 and 9, I get +8. Yes. Last example that I'm going to show you, multiply to 36 and add to 12. So they have to add to a positive and multiply to a positive. So they both have to be positive. So I can start with 1 and 36. They don't add to 12. 2 and 18 multiply to 36. They don't add to 12. 3 and 12 multiply to 36, but they don't add to 12. 4 and 9 multiply to 36, but they don't add to 12. They add to 13. Now notice, we're getting closer to a sum of 12 though. We got 37, 20, 15, 13. So hopefully our next pair will add to 12. 5 is not going to be a factor. but 6 will be because 2 and 3 are both factors. So 6 and 36 divided by 6 is 6. And 6 plus 6 is 12. So our numbers are actually the same, 6 and 6. So here are, I don't know, a dozen, maybe 10, 11. And there's a whole big table in your note packet if you copied it or picked up a copy. The ones that we didn't fill out, I am going to give you, like I said, the opportunity to fill those out, complete that table, and turn it in for extra credit. So everyone always asks, what can I do for extra credit? Here's what you can do for extra credit. All right, so like I said, here's the whole table. The ones that we did, you'll be able to, so just look for the number, and you'll be able to fill that in on the extra credit sheet. All right. So that leads us to this sum and product puzzle, which is going to lead us into what we're going to do next week. So what we're going to do is look for two numbers that multiply together to get the top number. So they multiply, in this case, to get 30, and they add to get 11. Again, knowing the factors is going to be helpful. If you're not sure of the factors, making a list is always a good option. So numbers that multiply to 30, 1 and 30, 2 and 15. 1 and 30 adds to 31, not 11. 2 plus 15 add to 17. So getting closer. 3 and 10. They add to 13. I'm even closer yet. 4 is not going to work. It ends in 0, so 5 will work. We get 5 and 6. So those are my values. Multiply to negative 11 and add to negative 10. So one has to be positive, one has to be negative. And actually, because they add to a negative number, I know that my larger factor has to be the negative one. So 1 and negative 11 multiply to negative 11. And if I add them together, I do get negative 10. So it's kind of nice, a good review of factors of numbers, kind of an interesting way to organize those factors. So again, multiply to the top number, add to the bottom number. So they need to multiply to a negative, but add to a positive. So now the larger factor has to be the positive one. It has to be the positive number. So again, I could start with negative 1 and 20. They multiply to negative 20, but add to 19. Negative 2 and 10. Multiply to negative 20 and add to 8. That's what I'm looking for. The order or the placement of the numbers on the left and right doesn't matter. I could write the 10 on the left and the negative 2 on the right as well. So that doesn't matter. multiply to 63, add to negative 16. Now I know the only way I can have two numbers that multiply to a positive value and add to a negative value is if both numbers are negative. -1 and -63, they add to -64. 2 isn't going to work, but 3 will. And that would be -21. They add to -24. Not quite right. 4 will not work. 5 will not work. 6 will not work. 7, -7 and -9. And they do add to -16. So that's our pair. All right. So we're going to take a minute and go to our breakout rooms, and I will meet you there. I was told that there were some issues opening the quiz from 7.1 and 7.2. That has been taken care of now. I, for some reason, did not enable the submissions. They have been enabled now, so you should be able to get into that quiz if you tried and haven't been able to. It is open now. All right.